Hey, what is up, you guys? Guys, welcome to another episode on the Incredible Academics YouTube channel. So we're gonna be going through Trig 3D, and let me just check if you guys can actually see. Right? Yes. I don't know if the right handwriting is legible, but I've tried my best to make sure that I make it as neat as possible. Yes, so PQ is a flagpole of height h meters, as you guys can see over there, and yes, we're given a flagpole and then there's a support over there. So PS is a stay wire to support the flagpole, right? That's our PS over there, and yeah, inclined to the horizontal at an angle of B. So there's the horizontal, this is the floor, right? So that's the horizontal, and I actually put that 90 degrees angle over there, but it wasn't there on the the original diagram. So yes, yeah, I just put it there because I know if it's a pole and it's on the ground, obviously it has to be perpendicular to the ground. And we also told that RQ and RS are equidistant, right? What is the meaning of equidistant? Equidistant, so obviously that means that RQ and RS are actually of the same length. So this is also X, and if this is X and that is X, you already know what this is going to be, base angles of an isosceles triangle. And now let's check what we're being asked to prove. So we asked to find the height, okay? And you can see the height has got the roots and stuff, right? So obviously sorry about that. You can see that the height has got the roots and all that, okay? And if this is the case, and you can see cosine has got a double angle, all right? Cosine has got a double angle. When cosine is involved, chances are that we're operating in the right angle triangle, or we used cosine rule, right? But if there's roots like that, just know that cosine rule was involved. So somehow you need to use cosine rule to understand. So what we're going to do is we're going to say fine. Let's start off by identifying the link, okay? We need to first of all identify the link. The link here is QS, which is the side that is common to both triangles that we're looking at. All right, so this is just triangle 1, this is we'll call triangle 2. Right, now the two triangles are linked by a common side, which is QS. So we'll operate in one triangle with the aim of finding the length of QS, and then we take the very same length of QS and use it in the other triangle. That's why we call it the link. Right, so now let's see if we can do that. But I mean, if this is alpha and that is alpha, you know that this is going to be 180 minus 2 alpha. All right, 180 minus 2 alpha. So we can go right ahead and try and find QS. Yeah, so we'll use cosine rule, okay? So QS squared is going to be equal to what? X squared plus X squared, all right, the two sides over there, minus X times 2 times X times X, all right, 2 times X, and then the cosine of the included angle, which is 180 minus 2 alpha, okay? So we try and simplify that, so this becomes 2x squared, and then plus, you'll see why I'm saying plus, x squared, the cosine of 2 alpha. So this is, remember, this is a reducing formula. in the second quadrant, cosine is negative. Okay, so negative, and that negative becomes positive. So when we reduce it, then becomes just cosine of 2 alpha. Okay, so now to simplify further, QS becomes the square root of that. So you can see that there's a common factor here. All right, you can see that there's a common factor. So we can take x squared out, and then 2, right, plus 2 cosine of 2 alpha. All right, therefore this becomes x into the square root of 2 plus 2 cosine of 2 alpha. Okay, and you can see that within the root or the radical, we still have what we call the a common factor, which is 2, right? 2 is appearing on the left of the plus sign, even on the right of the plus sign. Okay, so let's take it out. The reason why I'm trying to take it out is because I looked at that and I was like, oh, they factorized, you know, the 2 has been factorized, so I'm going to do the same thing here. So it's very important that when you simplify, you also take a look at what you're working towards, you know, cosine of 2 alpha. All right, so that's that. And then now that we've got our QS, we're going to use it in the other triangle. Remember, we found QS using triangle 2. Now let's answer the question, because we've been asked to actually find h, the height. So we are going to use QS that we found from triangle 2 to then find our h. Okay, so h over QS is equal to what? Opposite over adjacent is equal to what? So opposite over adjacent, which is QS, must be equal to the tangent of the angle beta. Okay, angle beta. So now this becomes what? H is equal to Q, let's just say the tangent of B, and then times QS. And we already know what the QS is. Right, QS is just that. Okay, so the tangent of beta, x square root of what? Square root of 2 into 1 plus cosine of 2 alpha. All right, so now this is starting to look a bit familiar, so we can rearrange x tangent of beta, the square root of 2 into 1 plus the cosine of 2 alpha. Okay, I hope you guys can see. So that's our height, you guys. Okay, and obviously once you've got the height, the second question says if x is 2.58 and alpha is 58, beta is 64, find h. So h is given by that x as 2.58 meters, and the tangent of the angle beta, which is just 58 degrees, the square root of 2 into 1 plus the cosine of 2 times the angle alpha. You guys can't see the angle alpha. It's what? It's 64. 2 times 64 degrees. Okay, we do the substitution and we find the value of height. The height 2.58, the tangent of 58. I hope you're also using your calculator over there, because people get surprised when the calculator is giving them some weird answers in the exam, whereas they never really actually took that time to use their calculator, you know. Yeah, it takes practice, you know, understanding your calculator and all that. So the answer is going to be 3.92 meters. All right, 3.62, not 92, sorry. So that is that, you guys. That is that. So I'm not gonna waste much time. I want us to quickly look at this one, and I'm pretty sure we're going to destroy it. Okay, we're not gonna waste as much time on this one. So you can see the diagram over there. I tried to draw it nicely for a change. In the diagram, PQ is perpendicular to the horizontal plane QRS. So the horizontal plane, that's your QRS. So you're supposed to have Q here. QRS, this is the horizontal plane. In other words, this is just the ground, and PQ is perpendicular to that ground. And then RS is given as X, QRS, that angle over there, that's alpha. And then QSR, the angle over there, that's beta. And we've got the angle of depression over there, which is theta. You can see that this dotted line over here is actually parallel to that QS. All right, and then we've been asked to show that the distance from P to S, let's see, P to S. All right, so we're asked to find PS actually, is given by this. Now the big question is, can we actually do that? I'm saying we can only find out by doing the actual work, right? We are about to find out. Let's see. So look, remember, we're gonna label the triangles 1 and then 2, or you can say 2, I mean 1, 2, the other way around. So it doesn't really matter which one is 1, which one is 2. You understand? So let's go right ahead and simplify. So the first thing that I'm going to start with is that if that angle over there, if the two lines are parallel, that angle there is theta. What can you say about the angle over there? I hope you said theta as well. Alternating angles. For as long as it's parallel lines, we're definitely going to have alternating angles. So remember, to find our PS, in my opinion, we need to use the link. We always have to find the link, trust me, because you need to find the link, in this case obviously it's QS. You need to find the size of the link in the other triangle and then use it in triangle 2, right? So you find the length of the link in triangle 1, then use the very same length that's found in triangle 1 in triangle 2, you know? That's what we use the link for. We operate with the link in one triangle and then still the length of that, you know, link to the other triangle, because the link belongs to both triangles. All right, so okay, now to find the length of the link, but you can see that over there is simply 180 degrees minus alpha plus beta. Okay, 180 degrees minus alpha minus beta. So that's that. Okay, and you can see that there's actually alpha plus beta in our final, you know, answer there. So this is going to come in very handy. So remember, the main aim in triangle 1 is to find the length of QS, so that we use it in the other triangle. QS over X is equal to what? So QS over X, no, not QS over X, it's QS over the sine of alpha. Okay, sorry about that. So QS over the sine of alpha. So now we're now using sine rule, is equal to X over the sine of 180 degrees, which is that angle, 180 degrees minus alpha plus beta. Okay, so now let's first simplify that. QS over the sine of alpha is equal to x over what? The sine of alpha plus beta. Still remember your reduction formula. Yeah. And then, now we make QS the side with the formula. We simply multiply both sides by what? Sine alpha. Sine alpha. Okay. So QS must be equal to x, the sine of alpha, over the sine of alpha plus beta. Hope you guys are happy with this. So now that we found the length of QS, it's easy to find the length of PS. Okay, the length of PS, very easy to find. So we're just gonna say QS over PS, right? QS over PS, and if you check QS over PS, that's adjacent over hypotenuse. All right, so this must be equal to the cosine of the angle theta, cosine of theta. So, but we already know what QS is. Okay, what we're gonna do is we're just gonna say, okay, this is the same as cosine over 1. So PS, we cross multiply, times cosine of theta must be equal to QS times 1. QS times 1. Therefore, PS is what? QS over the cosine of theta. But what is QS? We already got QS over there. So x sine of that over the sine of alpha plus beta, that's our QS, divided by the cosine of theta, but we can change division to multiplication. So x sine of alpha over sine of alpha plus beta times 1 over the cosine of theta. Now, what is that? What is that? Simply x sine of alpha divided by the sine of alpha plus beta and then cosine of theta, which is exactly what we're being asked to prove, right? Exactly what we're asked to prove. Okay, so we got it. Ladies and gentlemen, we've come to the end of the lesson. I hope you guys enjoyed it. I hope you guys are going to share with friends and family. Let's let people know about this channel. Let's crash maths. Don't be selfish, right? Because I wasn't selfish to you as well, right? I just decided to, upload these videos so that you guys get some value, right? Maths in South Africa, it's not as easy as people make it seem. So, in other words, we just need to put in the work. You know what I mean? We just need to put in the work. If you do some sacrifices and all that, it's definitely going to work out for you. Yeah. Maybe it might take a little bit of time, but yeah, eventually you're going to crack it. But otherwise, I'm out of here, and peace out. Sure.